Discuss the design build life cycle and the flow of data across the different phases of the design build process. Now, the machines we've been looking at, of course, are part of the building process, but they're certainly a result of good design. And one client told me one time, I thought it was a great analogy. He said that these machines, they're great, sexy watching them operate, but they're just like a printer. They're going to sit there and do nothing without data. And if they get bad data, then they're not going to perform well. So can't stress the importance of good data and being able to make that data convert and be compatible with the different machine control systems available. So when it comes to data flow across the design build life cycle, basically, and this will be an oversimplification, we start with data collection. We go out and collect data from a site. We take that data, we bring it in, often a site topography or what have you. We bring it in and we apply the design of whatever it is that we're building. I've got a rolling hills and I'm going to cut a highway through it. I've got a farm and I'm going to put a retail shopping mall on it. So we have to go collect that existing data first, then design what it is that we want, and then we prepare that data and make sure that it is in a format to load into the machine control systems. And this often, of course, involves a digital terrain model, or DTM. There's also line work. There's GPS localization. There are road profiles. It just depends on exactly what the application is. And another item that some of the machines are capable of doing are logging files for all of their positions and what they're doing. And by this I mean you can actually use the machine. These systems are accurate enough to basically gather a real-time topo, updating the grid and the surface with each pass of each machine. So really, at the end of the day, you should have an accurate topo or as-built of what the machine actually did that day. And from this, we can determine a lot of things: analysis, how productive are the machines working, different reporting that can be generated from this data. And certainly with this flow of data from, again, across the design build life cycle, data compatibility is critical. So be sure that that you understand and that you apply testing and know what data you're getting, how that data flows. Does it need to be converted? Do I lose information when I make that conversion? But certainly all of these require an end goal of data standards, so that this is opened up so that everyone can work with everyone. And doesn't matter what data collection software and processes are being used, what design software and processes are being used, which machine control system, so on and so forth. So if you have data standards in your area or can participate in that, it's really a good idea, because it just takes all of this technology to the next level, increasing the adoption rate, etc. Again, as I mentioned earlier, data is a critical component for successful machine control implementation. Absolutely critical. It is the fuel for positioning. And again, the machines will just sit there and do nothing, just like a printer, if the data is not available or the data is not accurate. Now, this will show a drive-through or fly-through of a digital terrain model before any dirt is moved. So we can actually see that we've got some problem areas here. There are spikes in the elevations in this road design. We can see the simulation having issues as it goes across the digital terrain model, or DTM. Now, this is fantastic, the ability to be able to fix these possible situations and errors before ever getting out of the site. It's always easier or the dollars are much cheaper to fix in the office in the virtual world than outside on the actual job site. So now let's discuss taking all of these 3D machine control systems, whether it's, again, dozers, drills, compactors, whatever the application, whether it's a standard application, traditional application, or a unique application of the technology. The connectivity gives us the ability to tie all of these together, creating bidirectional data flow. Very good for remote monitoring. Anywhere in the world, we can go in and not only monitor a site, but monitor each machine, even going in and troubleshooting the particular machine. There's a sensor that's bad. There's a data file that's bad. Load a new data file. All of this can be done remote and made available by remote monitoring. Also, if we have everything connected together, we can also set up proximity warnings, and this is a good safety feature. If two machines are getting within a certain proximity of each other, and everything is connected on a network, then proximity bubbles can pop up and warn each operator that they are getting close. And each operator is able to see all of the other machines that are working on the site. Again, being connected, we can bring all this data in, stream it in. We can perform productivity analysis. Why is one operator more productive than the other operator? And we can also use historical playback. I can go back and get data for one or more particular machines and say, you know, let's watch this machine operate. Maybe they went over a bank, or maybe I want to measure their productivity and use that good productivity to help train another operator, so we can replay what these machines are doing in the 3D world. We mentioned populate data, being able to make sure that all the machines have the current design. Change orders and all of those things are a realistic part of this business, and connectivity and machine control systems and being able to manage and populate that data is a big feature. Again, reporting, very, very powerful. Being able to create custom reports that summarize activity and productivity and job site progress, very important. Here is a piece of software, Fleet Manager Office, that shows multiple machines operating on a site. I've got a compactor, several dozers. The red dots show me that they are currently connected. I have a Fleet Explorer on the left, and I can group these fleets however I want to, turning them on and off. I can go in and select the properties of one of the machine rovers, get their ID, the task that they might be on, their IP address. All of these things are very valuable for doing productivity analysis. I'd like to provide a reference for this type of technology, some of the things that we've been discussing. Machine Control Online, I'm involved as editor of this site, is basically a collective knowledge base to promote all things positioning, all things machine control. It has several application articles. There are dedicated authors that produce monthly columns. There's a free newsletter that comes out twice a month. And we have a lot of exciting media vehicles for the future. So please visit Machine Control Online, sign up for the free newsletter, and stay in touch with this very exciting and emerging technology. So I'd like to thank Ron Singh and his team again, the Oregon Department of Transportation. For more information, there are a couple of websites listed on the screen, my email address, and my mobile number. Thanks again for the opportunity, and I look forward to hearing from you.